Hey guys, we're going to cover 6-4 today. This is called dilations. And the textbook definition of a dilation is a transformation that enlarges or reduces a figure by a scale factor relative to a center point, which is called the center of dilation. So if you're following along in the book, you can find this information on page 484, 485. The only other vocab term here is scale factor. Scale factor in this book is known as K. I've seen it referred to as R. It doesn't really matter what letter is used. It's really just a symbol that represents a scale factor. So textbook definition of a scale factor is a positive value. This is really important, positive value, that you multiply each X and Y value by to enlarge or reduce the image. So I want you to think about something here for a minute. If you want to double a side length, obviously you would multiply the side length by 2, right? But what if you wanted to shrink it by 1/2? So that would be a reduction. What number would you multiply each X and Y value by? It tells you right here that a scale factor must be positive. So a lot of times people think, oh, you would just multiply by a negative number. Well, not necessarily, because remember we're talking about distance, and distance can't be negative. So you're trying to think of a value that you can multiply by that will shrink a dimension. So basically what happens is when the scale factor, remember K really means scale factor, when the scale factor is greater than 1, any number greater than 1, you're going to get an enlargement. So here we have K, our scale factor. If it's greater than 0 but less than 1, so between 0 and 1 basically, I know this is kind of confusing symbols here. This really means between 0 and 1. That's actually going to be a reduction. So in other words, if scale factor is larger than 1, the shape is going to get bigger. If the scale factor is between 0 and 1, so we're talking about decimals and fractions, the shape is going to get smaller. Okay, so I'm going to go ahead and take a look at example A, and this is going to be on the bottom of page 484. Okay, so they're not giving you a graph here. They're just basically telling you that there's a figure. It has the following vertices. W is located at -2, 4. X is located at 1, 4. Y is located at 3, -1. And Z is located at -3, -1. So we have 4 vertices here. This is some kind of quadrilateral. What they want you to say, hey, what are the new vertices after you apply a dilation with a scale factor of 2. So what I did is I went ahead and I listed out the original vertices. Here they are. If you want to skip this step, you can. So here's kind of what I like to do is you can go ahead and write the original vertices, but you're going to leave some space. So what I'm going to do is I'm going to plop in the scale factor right next to each X value. I'm going to plop in the scale factor right next to each Y value, right? It tells us that our scale factor is 2, right? So K is equal to 2. So is this going to be a reduction or an enlargement? Well, 2 is greater than 1. So this is going to be an enlargement. If we were to graph this quadrilateral out, the image would be larger than the pre-image. It's going to be an enlargement. Okay, so our scale factor is 2. And so let me go back to the vocab here, and let's read scale factor one more time. A positive value that you multiply by each x and y value. A positive value that you multiply by each x and each y value. Okay, so we're going to take our scale factor of 2, and basically we're going to multiply it by each of our x values, and then we're going to multiply it by each of our y values. Scale factor is the same for the x and the y, so in each case we're multiplying by 2. Okay, so let's go ahead and I'm going to write w prime. So you're going to say, well, negative 2 times 2, that's negative 4. And 4 times 2 is 8. 1 times 2, let's see here for x prime. 1 times 2 is 2. And 4 times 2 is 8. Y prime, 3 times 2 is 6. And negative 1 times 2 is negative 2. And let's see here, z prime. Negative 3 times 2 is negative 6. And negative 1 times 2 is negative 2. So w prime, one more time, negative 4 comma 8. X prime is going to be 2 comma 8. Y prime is negative 6, negative 2. And z prime is 6 comma negative 2. Okay, so this is basically the solution. Dilation is all about multiplication. You're basically just going to be you're going to be multiplying each x and y value by a scale factor. If that scale factor is larger than 1, you're going to get a larger shape, which is an enlargement. If the scale factor is between 0 and 1, you're going to get a reduction, a smaller shape. So they don't have any of those practice problems in this lesson, but here's an example of what you're going to see. If you take a look at number 2, example 2, and this is going to be page 489. Let's see here. The pre-image is the triangle in blue, and here are the original vertices, 3 comma 8, 10 comma 6, 8 comma 2. They are saying to multiply each of these values by a scale factor of 1/2. So it makes really no difference to me if you want to keep this in fraction form, or you can convert it to a decimal. The only thing I'll say is if your scale factor is a repeating decimal, leave it in fraction form. So you don't forget about on the calculator AB/C, right? That's a good option. Or, in this case, you can just turn it into a decimal 0.5. Either way is fine. So they took each of the original x and y values. So 3 comma 8, 10 comma 6, 8 comma 2. There's those 3 original x values. The y values here are 4. Whoops. The original y values are 8 and 6 and 2. Each of those gets multiplied by the scale factor of 1/2. If you're multiplying by 1/2, you're essentially dividing by 2. So half of 3 is 1.5. Half of 8 is 4. Half of 10 is 5. Half of 6 is 3. Half of 8 again is 4. Half of 2 is 1. So here are the image vertices. So if you go ahead and plot those out, you're going to see that you have a triangle that is a reduction. It's smaller. Okay, so there's one other thing I'm going to have you guys look at, and it's going to be example C. So actually, before we talk about jumping into C, take a look at example 3 on the bottom of page 489. It says, through a microscope, the image of a grain of sand with a 0.25 millimeter diameter appears to have a diameter of 11.25 meters. What is the scale factor? So the question here is, you know, it's not like, hey, what's the image and the pre-image. They're telling you what that information is. They're actually asking you what the scale factor is. What is the scale factor? So basically what you're going to do for these ones is it's going to be a division problem where the dilation gets divided by the original or the actual size, and that's going to tell you what the scale factor is. So if we see here that, let's see in pink, the dilation is 11.25. I think maybe I miscolor coded these here. 11.25. And in reality, it's 0.25. So let me fix these. Let's see here. So in reality, this is 0.25 of a millimeter diameter. The dilation of that is 11.25. So there we go. I had those two mixed up. So if you go ahead and plug these into a calculator, you're going to see that 0.25 goes into 11.25 45 times. So that tells you that the scale factor is 45. So in other words, the microscope zoomed in at a factor of 45 times of the original diameter of the grain of sand. Okay, so let's go ahead and take a look at example C. So turn the page. This is going to be the top of page 490. So we want to figure out which one is the original and which one is the dilation. Okay, so I'm going to go ahead and I'm going to copy what I did here. I'm going to say K is equal to dilation over the original slash actual. The scale factor is equal to the dilation over the original slash actual. So the real dimension, right, is basically what I'm referring to here. So just be consistent with my color coding. I have the dilation in pink. And I have the original or actual size in yellow. Okay, so Lucas wants to enlarge a 3x5 photo to a 7.5 by 12.5 inch photo. What is the scale factor? Okay, so the original size here is a 3x5. That's the actual size of the photo, right? He wants it larger. He wants it to be an enlargement. He wants it to be a 7.5 by 12.5 inch photo. So I'm going to go ahead and I'm going to plug in the dilation up top, which is going to be 12.5 by, this doesn't mean, right, this doesn't necessarily mean times, it means by. So 12.5 by 7.5. You know what, I'm going to be consistent. I'm going to put the 7.5 first. 7.5 by 12.5. Okay, I'm going to go ahead and in the denominator, I'm going to put 3x5. Okay, so this looks scary because you've got fractions on top of fractions, you've got division, you've got what looks like a multiplication symbol. Here's my suggestion, is just treat each one of these as two separate division problems. So essentially, 7.5 divided by 3 and 12.5 divided by 5. So let's just do some quick calculations here. If I plug in 7.5 into my calculator divided by 3, I get out 2.5 or 2.5. I should get the same answer here. Let's try it. 12.5, 12.5 divided by 5. I still get 2.5. So you're going to get, it doesn't really matter which of these two you choose to do, you should get the same scale factor either way. So I know that this is going to be an enlargement of 2.5 times. So the scale factor here is going to be 2.5. All right, guys, that's pretty much it for today. Go ahead and see what you can get done in the homework. My apologies about the password situation yesterday. I didn't know that passwords were required. When I was doing Zoom meetings a couple of weeks ago, they were not. So apparently they're required now. So when I post this, I will put my meeting number as well as my password. So sorry about that confusion. So the other thing is, I think what I'm going to do is anything that you send me in terms of homework, I'm going to enter into Aries as extra credit. I'm not going to make it worth as much as a full assignment because I don't want to inflate grades too much. But basically, whatever you guys take a picture of and send to me, I will enter as extra credit. So if you're not able to send me photos, I know some of you guys are having difficulty, it won't count against you. And then the other thing I'm going to do is I'm making an attendance assignment that I will post in Google Classroom, and it's going to have a couple of multiple choice math questions related to what we've been working on. And basically this is just credit, no credit. So if you attempt it, you get credit. If you don't attempt it, you don't get credit. And so this is how I'm going to keep track of your weekly attendance. Okay, so I will be available on Zoom tomorrow at 11 a.m. If you guys have any questions, I will be going over Chapter 6-4, that's Dilations, the homework assignment for that. All right, I'll talk to you guys later.